And we're streaming.
We're live.
Hello.
Hey, Matt. Hey, Katharine.
Hi, Hugo. Hi, Matt.
I got to do that too. Hi, Hugo. Hi, Katharine. Yeah, Hugo, I'll have you
I like that.
in just a second.
Hi, Hugo. Hi, Matt.
Keep going, Katharine. Keep going.
Awesome.
Hi, Katharine. Hi, Matt.
We're
is
good.
this,
Hugo,
is this a memorization game?
We are live now.
Yeah.
Welcome,
Hugo,
everyone.
yeah, go for it, Hugo. Yeah. So welcome to Coiled's fourth stream. Here we have
Correct.
Katharine Jarmol. I'm going to sort of riff for a while Hugo is tweeting things out into the ether, violating everyone's privacy. Hugo, I love your background, by the way. Thank
you. I wasn't there myself, but it definitely is a deep concern for privacy for everyone. And I thought it was great. I found a photo which had a little Washington Post watermark, which I thought would be a great introduction to Katharine's illustrious history. Maybe you could start by telling us a bit about yourself, Katharine.
Yeah,
Tell
sure.
us about yourself.
Sure, no problem. I'm Katharine Jarmol. I go by KJM on the internet. I know Hugo because I was one of the teachers, I think one of the first Python teachers for outside of yourself for
Absolutely.
data. Correct.
Correct.
Yeah.
And the first natural language processing course, which we had a lot of fun building together.
Okay, yeah. I thought maybe there was one in R already, but excited.
No, there was. I'm sorry. Yep. Okay. The first one in Python.
Yeah. And we got to know each other, and since that time, I've gotten more involved in data privacy in data science and machine learning space for, I guess, now the past 4 years or so. However, I did begin my Python journey at the Washington Post. I was a data journalist, and I worked with the local desk to kind of report and build data interactives, data applications. And I learned Python there, which was pretty cool.
What does that mean? So I'm curious, what does that mean? It's like a news story happens, some dump of data of, Ebola spreading or something, and you're asked to quickly make a map or quickly make like a clickable thing. You have to like make that in 24 hours before the story goes out or something like that?
Pretty much, yeah. I mean, especially when we had breaking news, we would, try to do breaking applications as well. There's also some longer investigative pieces. So some of my colleagues, for example, this is after I left, but used Hadoop EMR, I believe, one of the first cloud instances to go through some of the papers that were released related to the Panama Papers and this type of stuff. So there was some fun stuff happening on that team of figuring out how we can use data to tell stories.
Yeah, that's super exciting. It's fun. Journalism has like an interesting story with Python. I think Django came out of the New York Times. Is that right? Right?
It came out of, it was Lawrence, Kansas, if I recall correctly.
Oh, okay.
It was the newspaper in Lawrence, Kansas. Yeah.
You're trying to get all the credit, good or bad.
It's all good.
But yeah, no, Python was useful for rapid prototyping of things. And it turns out that in journalism, you need to build things rapidly. Time to futz around. So yeah, cool.
Are you both going to introduce yourselves, or am I a lone introducer?
I would love to introduce Matthew. So Matthew Rockland is one of the creators and maintainers of Dask, and the CEO of Coiled. And I'm the head of data science evangelism and marketing at Coiled. And at Coiled, we're building products to scale existing Python workflows and to make enterprise and collaboration ready Dask-based projects. So maybe Matt could say a couple of words about Dask, and then we can jump into the meat of it.
Sure. I've been doing a trick recently where I just ask our guests to introduce Dask. So at the beginning of this podcast, Katharine, you said, "Oh, I know Hugo." I felt really bad because you also know me.
It's true. I know you before I knew Hugo.
There we go. Yeah. So
Hey, it's not a competition.
It's definitely a competition.
Okay. It's a
So
competition.
I first saw Katharine when on Twitter, like years ago, like well before Dask was well known, someone was giving a tutorial on Dask, like somewhere in Europe. Like, who is this lady giving Dask tutorials I've never heard of before? So Katharine's talked about Dask all the time. Can you give a quick introduction to it?
Yeah. So, I mean, I found Dask, and I found Matt, who I would say is like the most humble and awesome person who has created an amazing library that I have had the opportunity to
True.
chat
I am
with.
the most humble person.
I
You
remember
shouldn't have said that, by the way.
I think I emailed you, Matt, and I think I was having some problems with like getting, I think it was the initial EC2 implementation, and I was running into some issues, and it was still very like developmental at that point in time, in terms of like getting everything to the cluster to go up and down. And I was curious if I was doing it right and these types of things. Anyways, you totally helped me out and helped me reason about Dask and what I should use it for. And I remember pointing it out to folks because I think at that point in time, I had some exposure to Spark and some exposure to some other of these like EMR, again, as I referenced, and Hadoop. And they were always these big, clunky, hard to use things. When I first heard about Dask, I was like, wait a second, so I can build this. I can stay in the Python world, which makes me happy for not having to figure out how to get, Hadoop running on my machine. And I can also like experiment, and I actually like can reason about everything that's happening, which I didn't feel like I could do when I'm in the Pi4j land. So, and it was just really easy to get started. So I gave a few talks on it. So Dask is something that you can use for distributed data science, or what's called out of core processing. So the story I like to use is, let's say that you have a data set and you would rather not maybe upload it all to the cloud at once so that somebody else could process it for you. You can do that yourself. So that's one cool thing, both from a privacy aspect and also from a cloud compute cost aspect. And then it also makes, I think, similar to like, let's say the rise of tools like Airflow, it makes Python a core and prime primitive, so to speak, for doing distributed data processing or data pipeline operations. And so those are like really nice things that still keeps you in this language or this paradigm that in terms of DataFrames and other things like this, where you can actually, let's say, like use the data science skills you already know and apply them in a distributed or in a larger data context. So
that's great.
Hopefully I pass that test.
What I like,
You get a 9 out of 10. And the only reason you don't get a 10 is because nobody gets a 10.
Okay, there you go.
I get a 10 sometimes.
Yeah, Matt gives himself a 10 occasionally. I never give Matt a 10. But Matt never gives me a 10 either. So, but yeah, you've spoken to some really, really key points there, I think. And in particular, that it allows you to work in your native PyData stack and ecosystem. And it's also running Pandas code most of the time in the backend when you're writing your Dask data frames, which for someone who's working with Spark currently, that isn't always the case. Spark has a lot of pros, but one con is that it's doing a bunch of stuff in the backend. That means your mental model may not map to what's actually happening there. I'd just like to ask everyone joining us to introduce themselves in the chat, where you're dialing in from, what you're interested in, why you're joining, what your job is if you're interested in sharing that as well. And to that end, perhaps Katharine, you can tell us a bit about Kate privacy, and then we can jump into some privacy preserving code.
Boom.
With Zuckerberg looking over both my shoulders.
I know. He's kind of looking out to the right, though. So,
Oh, that's good.
Looking askance, I think is the term. Looking askance.
He's really scared.
Yeah. So, Kate privacy. Kate privacy. We're hoping to kind of allow privacy and data science to work together. That's the main goal. And that means both from making open source, easy to use, easy to, again, like reason about and use within tools that you love, for example, pandas and other types of data frames. Making privacy tools there, right? Which I think, unfortunately is not the norm for a lot of privacy tools. And then also with some other things that we're working on our larger platform is about bringing privacy experts and data science or machine learning experts together so that we can actually have better data science and privacy at the same time. Basically meaning if we could get privacy professionals like legal professionals and so on to write policy alongside data scientists who are of course then the experts of the tasks that they're trying to do, then we can actually strengthen both, because with a lot of advanced privacy techniques, we don't necessarily, depending on the task, depending on the goal, we don't necessarily have to sacrifice the quality of our inferences for the sake of, or for giving up privacy, right? So there's a tension there, there's a natural tension, but there's also ways for us to alleviate that when we have the right people in the room talking about the right things.
Absolutely, and I think we're being sold something which, as you say, isn't quite true in terms of getting all the personalized recommendations we get and getting everything we get through machine learning algorithms. I think there's a commonly misheld belief that we can't have those things while preserving privacy, right? But the truth is, as we'll hopefully discuss later, we can. And to that end, to give kind of an intro to what we're going to do, correct me if I'm wrong, KJ, we're going to jump in and look at some privacy preserving techniques in pandas, and then in a distributed setting in Spark, and then discuss the machine learning setting, talk around that.
I'm with it.
Can we like make fun of you when we're doing Spark things?
Yeah, sure.
Fantastic.
All right, let me
and we also got Scott Barnett calling in from Steamy, New Jersey. And he says he'd give Matt, Hugo, and KJ a 10. So there we go.
Hooray.
Look at that.
More generous than me, clearly.
Yep.
Right. Ken, is the text big enough? This is the question.
I would maximize it more. And maybe if you can remove
I think you're
the
good.
toolbar as well, perhaps, but whatever.
How do we, my Zoom is over my toolbar. All right.
It's not a toolbar. Sorry, I've never said that before.
Is that better, sir?
That's great. That's awesome.
All right. So, I mean, some of the things that we wanted to chat about today is we have this Cape Privacy library. This is Cape Python that we released now, gosh, nearly a month ago. We have another release next week, so stay tuned for that. We can chat about it. That's more for like policy management. But the Cape Python library was built so that you could add some easy privacy techniques to any data science you're doing. It's primarily focused right now at kind of like EDA or pre-processing. We'll have more soon in the inference, machine learning, and analytics land, but this works really well for these types of things. Like you're in a notebook, you have access to some data, you start looking at it, and Hugo, what do we see here in the data?
We've got some timestamps, some names. We've got a temperature, a heart rate, then a commit tag. Is that what we're looking at there?
Some sort of unique identifier.
Yeah, some identifier, and then a couple of other things.
Yeah. Okay.
Like health data? Is this biometric data? Maybe.
Perhaps. Nice inference there, Matt. And what does the histogram show me?
So we're looking at the unique values of usernames. So you've got a lot of people with the same name.
A lot of people with the same.
as many entries with the same user. We think.
Yeah, so we have like most names are not represented many times, right? And then it goes down to some names are we have this like long tail.
You and I both totally failed at your quiz. We'll get better at that.
Yeah, but that's because you didn't label your axes.
It's true. I did not label my axes.
No, yeah.
In our defense, it is 6 a.m. for me and midnight for Hugo right now.
That's true.
Neither of our brains are working too well.
You're supposed to hold us together, KJ.
Sorry.
Right. Okay. So to recap, what we have there is maybe you need to recap it, but I'll try. A lot of names only occur a handful of times, but there are some names that occur a lot more.
It's true. And so here we can presume, or the example presumes here, that we're dealing with maybe biometric or something like an IoT, maybe like Fitbit style type of data or app data, right? And we have exact time stamps. So we have precise time stamps to the second of users of some health readings of them or their device, right? And we have a kind of almost like a over-representation, we can think of it. We have some users that are quite active within this, let's say, day of data or days of data. And then we have others that are maybe not very active. And does anybody know, or does anybody want to start thinking about what would the privacy implications of this data set be?
Well, we've found that one person really likes to run with their Fitbit or something for whatever reason.
Yeah. So, I mean, when we think about it from information leakage or from what we might start thinking about, there's a field of privacy called quantifiable privacy, where we try to maybe quantify the amount of information that we have about a person. Or the amount of privacy that they lose when we analyze their data. And here, for the folks that are over here in the 40s versus the folks that are here maybe have 2 data points or 1 data point, these folks have a lot more individual privacy loss or leakage of their personal information in anything that we do with this data. And maybe that's okay, maybe it's innocuous. However, we should maybe always consider that of who is at risk here if, let's say, something were to happen with this data set, or who are we representing? I mean, we can also think of this from just a machine learning ethics point of view, or from a representation point of view. Who here is overrepresented in the data and who is underrepresented in the data? And so when we ask those questions, we may or may not come to conclusions that we should make some changes with regard to, let's say, privacy, or also with regard to, let's say, the evenness or the distribution of people within our data set. If that makes sense.
That makes perfect sense. So the distribution of privacy is not uniform, essentially, and that's a huge concern.
Yeah. I mean, we could very much go into a little bit of philosophical things here. However, I'll just reference a book called Automated Inequality by Virginia Eubanks, and her thesis and what she brings a lot of data to in that book is that some people are quite overrepresented and don't have a lot of choices as to how their data is being used. For example, we can think of people that get social aid from government programs where quite a lot of data collection and automation is happening, et cetera, et cetera. So there is some links there between, let's say, like the freedom of privacy or the choice of privacy and those who may or may not have less access or choice there.
Absolutely.
Okay, and so so for this data set, I mean, presumably, right, I want to maybe make some inferences about, let's say, connectedness of temperature and heart rate over time. However, maybe I don't feel like I need exact times. Maybe I need, you know, it's ordered already, and maybe I can save some privacy of the user by making some choices. So I just wanted to quickly show here that these are kind of the initial transformations that we launch with. What a transformation is it's basically a way that we can use some of them fairly simple, some starting to become more complex, but we can essentially transform the data the same way we might when we're dealing with data in a data pipeline context or a data processing context. And we can say, okay, maybe I need less precision on this. Maybe I don't need the exact value on that. Maybe I can tokenize this or that value. So when I look at this data set, I mean, from a privacy perspective, I see the largest problem maybe with timestamps and with usernames. And this is because the timestamp, if I can link it to other information, this can often quite leak a lot of information. So the famous example of the Netflix data set, they were able to use the times of the reviews to properly link the Netflix reviews to reviews in IMDb. And this was one of the ways that they were able to de-anonymize the Netflix data set. It's a great paper if folks haven't read it, by Arvind Rayanan and sorry, the other very famous researcher, Chitowski, right? Vitoli, I can't remember. Anyways, and that paper is a great read if you're starting to get into how some of these de-anonymization or re-identification attacks occur.
And so in this case, how would you approach it? Or what's the simplest approach to, is it adding random noise or something along those lines?
I mean, so we can perturb the date. That's also something that we allow. One thing,
but you're truncating it here.
Yeah, so here, I mean, my first inclination is to truncate because maybe the date, you know, the dates and having them in semi-ordered form for my data science, maybe this is important. For that reason, perturbation, which may plus or minus dates, is maybe not a great fit for this type of data, or for this data science task, really is what it is. We have to kind of inform ourselves of both sides. So we have a date truncation here, which allows us to essentially change the frequency. So this is one such way that we can do this. I will point out that pandas is not being my friend here because my timestamp is an object, and based off of this, we can see that I need to have, actually, it's not listed here. However, the date type that we would like to have is a timestamp. So I'm gonna change it to a timestamp. I can see now that I have my timestamp column, and it is the proper D type of date times 64. And at that point in time, I can call on this date truncation. And now I still have, again, my same, it doesn't do anything for our typecasting, but it instead, of course, truncates the date. So now I have it on a day frequency rather than the hour, minute, second. So if I run that and do that, then I can see that I've updated my timestamp column by just passing it into this truncate date function. Essentially, right now, that's a method of these Panda transformations that we have.
Great. So that's our first Cape Python transformation.
Yeah, it's just there, and it's there to be useful for you. I mean, we have numerous ones, and it's just supposed to be super easy for folks to use.
And we've linked to the docs, but people can pip install it, Cape Python?
Yeah, pip install Cape Privacy.
Of course, yep. Great. So now we're concerned about the username, as we hinted at before, because of the uneven distribution.
This is correct. So the tokenizer is applies tokenization. For folks not familiar with tokenization, so essentially you can think of this as a hashing mechanism. And so for tokenization, we can do truncated tokenization. So we can set a max token length. And this means that the resulting strings can remain short or long. And then we have a key, and this key is used as part of the hashing mechanism. And there's a warning on this within the documentation that we can talk about. One problem is that we have a key here, right? So if you continue to use the same key, you will get the same output. And this means that given the same key and the same input, hashed or tokenized together, then you get let's say a deterministic solution. So you always get the same output token. And because of that, this could be prone to what are called linkage attacks. And so linkage attacks mean that if I have enough data, and let's say I have data maybe even from different sources, then if I can identify one individual, let's say via some other linked data that I have, then this could potentially be a privacy violation. So what we want to make clear here in releasing the tokenizer is it's great for, let's say, like a curious but honest user. So it's great for, let's say, I don't really want somebody to go searching Michael Smith and to figure out, where he lives and what he does and these types of things. But I do, trust that the person's maybe not going to try to do other types of attacks on the data itself, which I feel like is most data science, right? We tend to trust one another. We trust the other folks working in our organization. So it's just a small thing that you can do to add some privacy there for the individuals whose data that you're essentially custodian of. Does that make sense?
It makes perfect sense to me.
All right, so I have the tokenizer. I've given it a key. I've given it a max token length. I can test it. I see that I still, again, from the value counts, we still retain, let's say, these larger users or these more active users. However, we don't have their actual username when we're doing the data science. So one example could be that I then replace that username and then I write this to a file or normally a database and say, okay, now this is the table that we're going to use for our regular data science. It's had a few things applied. It's by no means anonymized. It's by no means has removed all personal information. However, we've obfuscated some fields in the hope that we can protect the privacy slightly more than we were previously by just using completely raw values all the time.
So when I look at this, sorry, I got some dumb questions. When I look at this, I think I could have done all that. Like I could have written some pandas code and done all of those things. We probably would have done it like slightly wrongly. Like I'm probably good at running pandas code, but not so good at like thinking about the fine details of privacy. And so what you've done here is you created a pre-processing package that has a lot of sensible choices built in. So I can use these choices and know I'm probably doing, best practices in this field. Is that fair?
Yeah, I think I kind of see it as an easy introductory package for folks so that, as I hope data privacy becomes slightly more, let's say, popular or known area of data science, these are kind of some nice basic steps that I would say, we can universally use and are hopefully a starting point to start asking deeper questions about data privacy in general. But yeah, I mean, the point of us really releasing it is yeah, of course, you can map your own columns and you can apply these things, but why not, we don't always have to do things the hard way or our own way. We can also use libraries that are there, again, as you know, written by folks that, have studied these things and can give you just a few little helpers, right? Similar to Pandas itself, right? So.
Especially in a situation where it's really critical. So like with security, I don't write my own security, I use OpenSSL because I don't trust myself to write that code. The changes you've made, this reminds me of the New York City taxicab dataset, another sort of famous privacy fail, where they just like hashed all of the medallion values, but they didn't precede it. And so here I see that you've got a seed that you're going to be salting that with. And over time, they've also been removing certain columns. They've been fuzzing the location data because it ends up resulting in lots of privacy violations. And so we've seen that fuzzing before where you're truncating. And so if you watch that data set over time, I'm seeing, when I look at your API, I'm seeing lots of the same kinds of things that they've tried to do, did poorly, and then had to figure out the hard way that they really should have done best practices. If they had used something like K-privacy from the beginning, they would have made the right choices early on.
Yeah, I mean, some of it is about asking the right questions. So currently we're also trying to work on some, some easy materials, easy materials that allow people to kind of start to ask these questions themselves and help make choices about what types of transformations you might need for what types of data or what types of tasks, data science activities that you're doing. But yeah, I mean, the point is that you shouldn't have to be a privacy expert to care about privacy, right?
Or to be able to do it as well. And I think what you're doing is building tools to facilitate people, not only in programmatically and computationally doing it, but from the way you've explained it, from the API, from the docs, you're actually helping people to reason about it as well. And I mean that in a very explicit sense, in that data science still is a collection of ad hoc tools developed to solve particular problems, siloed tools as well. And so privacy concerns crop up everywhere. So developing almost a rationale or a mode of thinking or processes around these types of things is what I see kind of budding here in a lot of ways. And a way of thinking about it, I suppose, is the short version of that. Does that resonate? A way of reasoning about privacy concerns.
Yeah. I mean, I think that you can go or I should hope that one could go as shallow or as deep as they want in any area within our field of data science. For example, I can use Dask without understanding how it works. I just know that somebody solved some of the hard problems for me, and I can trust that the right decisions were made there. And I know because it's open that if I wanted to, I could go line by line and look through the code and analyze it myself. And so I think that type of flexibility, right, of, hey, I just want to use it because I have this problem and I'd like to have something help me, to, wow, now I'm really into it and I want to dive deep and I want to ask, really hard questions about this stuff. I like to tell people I know who are into data science because they love math that quantifiable privacy is some pretty wicked math. So you can go as far as you want in the field. It gets pretty crazy, pretty fast in terms of data privacy, but we want to be there for you along the way in that, look, if you just say, hey, look, we should tokenize this data, we should perturb some of these columns, and then we're ready to go, it's there for you then. And if you want to start learning and reasoning at a deeper level about it, then we, of course, want to support those educational journeys. We're by no means the only ones. Open Differential Privacy, which is a really cool organization, I think supported mainly now by Microsoft, is also doing a lot of really cool work in the open. There's many other organizations as well. So
great.
We're a part
so
of
what I'm doing is
larger...
kind of allowing accessibility at a variety of different levels. I'd love to move on to this the distributed case now. But while we're doing that, we've got a great question from David Asabina. How would you fuzz coordinate data in a data set with your library such that I can hand it off to interns for experimentation. So this also speaks to data access, which I don't actually want to get into right now, but the fact that different people in an organization, I don't want to get into it, but let me just rant about it. Anyway, how would you think about fuzzing coordinate data, KJ, using Kate?
Yeah, I mean, so coordinate, I'm assuming means lat long or other types of location data. Yeah, I mean, we're gonna do that in this notebook, so we can talk about it.
No, let's just jump in. David, your question awaits an answer, but this is almost a cliffhanger.
Hold on. So I have a PySpark running just on my computer. And Matt, you already referenced this data set. So I'd love to talk about the New York City taxi data set. I'm using the 2016. So
KJ, I'd love to, if we could spend 10 minutes or so on this example in order to get to the machine learning stuff as well, just to give you a bit of a time.
Yeah, sure. Yeah, no problem. So this is the New York City taxi data. As Matt pointed out, this data set has a little bit of a notorious history within data privacy because unfortunately it was hashed in a way that was easily reversible, or tokenized, you can think of it in a way that was easily reversible. And for this reason, it was quite easy to figure out the taxi medallion. And those taxi medallions are like on the bumper, on the door of the cab, they're all over. They're like the main way of identifying taxis. And for that reason, they have to be legally placed a bunch of places on the taxi itself. And so one of the gossip sites was able to link all of the celebrities getting out of cabs with the paparazzi to their actual ride, where they started, where they ended, how much they tipped, these types of things. And, you know, that might be like, well, celebrities don't have a right to privacy. However, one could think that if there's any photo of anybody getting out of a cab, regardless of if you're a celebrity, it was quite easy to figure out where your ride started and ended, or getting in or along the way. So this was a really big problem, and it was a big privacy leakage problem. So they've since fixed that. They don't release medallion numbers anymore. But what they do release up until I think it was 2017 is they released latitude and longitude accuracy to, you know, I think it's like 7 percentile, 7 decimals, sorry, of precision. And for this reason, this is like, I didn't know much about this, but I read into it. So there's some links in this notebook. We can publish this notebook and share it. But there's some links to here to latitude and longitude. That's the level of precision of people that measure seismic, like microseismic activity. So it's like beyond knowing like where exactly in your house you are, right? So so perhaps this is a problem. Perhaps this is a problem that David, right? Was it David who asked? Who asked in the chat?
We've got someone else, Paul Zuradsky, asking similar questions. So
okay, cool. Yeah, and so what we would, sorry, go ahead, Hugo.
I just said it's front of mind, top of mind for many, which is cool.
Yeah, so I mean, so we have numeric perturbation. So that's one way. If within a few different, let's say, coordinate points, it's not a huge deal, then one could use perturbation. However, if you actually do need to use that location data, one thing you could think of is kind of similar to the date truncation. We can actually round and truncate. I will just share quickly this decimal degrees. This is how I learned about this. We can take the decimal degrees of GPS, let's say, and we can reason about at what level of precision do we actually need to think about it, right? So do we actually need to go down to the individual trees level, or can we actually think about it on the individual street level? We might even have some problems where just thinking about it as the street in the neighborhood is close enough. right? And so here's, some of the things you can think about is, at what point in time do I need that level of precision for what I'm trying to do? And at what point in time is it okay for us to reduce a person to or in the case to lose?
We've just lost your audio briefly, Katharine. If you wouldn't mind repeating. Oh, we may have lost her.
Oh no.
Star of the show, the glue. I'm just going to send her a message letting her know, because the great thing is she's actually typing. Oh yeah, oops, reboot is what she's typed.
In the meantime,
yeah, we've
so
got
let's talk a little bit. I have no idea how K-privacy works, but we can talk a little bit about some of the questions that are going on in the chat.
Yeah.
So Paul is asking questions about different kinds of transformations we might want to do. I'm looking at this problem about, I've got a round geographic location data. I think what New York City Tax and Livery Commission ended up doing is ended up breaking up New York City into lots of different regions, the different boroughs and the different zip codes in those boroughs.
Yeah.
So one could imagine taking something like GeoPandas, doing something like a spatial join. My guess is what Katharine's going to show us here is a bit more simple than that, especially because using Spark, and Spark is not going to integrate well with GeoPandas. If it's using Dask, maybe it'd be more easy to do that. But one might ask the question: how do I? If I've got some different policy I want to apply, how do I apply it cleanly? And yeah, that's actually all of the riffing I have to do. Hugo, any other filler material you can jump in here?
Well, there was a good question that Paul had around possible integrations with Dask. I don't have a good answer to that, but I was wondering if you had any thoughts about how long it would take to get Kate working with Dask.
Yeah, that's a great question. Let me wait. We've got Katharine. This is hilarious.
Nearly back. This is great. Yeah.
Yeah.
Have you ever been communicated with through a notebook?
Oh wait, she might be back.
Yes.
I'm very sorry. My tablet is misbehaving today.
It was so good because just before you disappeared, David wrote, yes, then a peace emoji, can't wait to see this in action. And then your mic drop. So let's do it. Let's do it, Katharine.
Yeah, let's do this. All right. So we can take a look within our Spark. We see that we have our data set. This is just a small sample of it. Of course, it does not look very pretty. Sorry about that. But the limitations of Spark in notebooks.
It's horrifying. The other thing that I just noticed that is probably worth mentioning is you can write your own policies in YAML.
It's true, yeah. And so whereas in the last notebook, we kind of did this interactive where you can kind of explore and see, does it work? We also have the ability to just write policy and apply it. So this is maybe after you've done EDA, when you're more like in a processing mode, like for example, maybe we're not using Spark to really do EDA, we're more using it to actually pre-process data we're going to share, again, with maybe other data scientists on our team. And here I gave an example of how to use the tokenizer. This is for vendor ID, which is actually okay here in this data set. They've obfuscated that enough, but I did want to give an example based on the medallion story. And then we have some perturbation for the passenger count. So this will either add 1 or 2 or nothing to the passenger count. This can be another way of protecting privacy, right? Where even though we're giving the exact location ID, we maybe no longer can reason exactly about how many people were in the car. And then we have the longitude, latitude of the drop off and the pickup. And I kept it to fairly precise. So this goes down to the individual street, but I was able to remove the very, very high level precision. I also redacted some columns that I actually don't need. So one thing I like about Cape Privacy is can also kind of use it to help pre-process. If you want to drop things, you can just redact them in place. So I can apply those. Don't worry about the warning here. We will make sure we get rid of that. It essentially says that Spark wants us to specify type hints. Currently, we don't explicitly do that in this way. And so now I've applied I've parsed the policy. I've applied it using Cape Python for PySpark. And then I can take a look at the Cape data frame itself. I will let these run. It will take a minute.
And while you're doing that, we have one quick question on perturbing data from John. Is there a policy for retaining order when perturbing? For example, timestamps retain order but are fuzzed a bit.
That is not something that we can guarantee right now. However, I would love that as a feature request. I think that's a great feature request. I mean, there's some other.
Do you encourage issues on the issue tracker?
Yeah. I just added one last night because I was annoyed that a feature wasn't available. So I was like, you know what? I'm gonna put in a feature request right now.
Awesome.
So, we very much encourage. We're also going to be releasing another library next week. That we hope is helpful, and some updates to this library will also come out next week at the end of this sprint, so to speak. So there's we're in continuous development on this stuff. So if you have feedback, please let me know. We also have a Slack community, so if you want to hop in there and chat with us, we're on there. And the team also has another community that we help manage called TensorFlow Encrypted, that's on encrypted machine learning. So if anybody here is into TensorFlow or already knows about TF Encrypted, that's we're the same team.
And that's maybe what we can chat about once we get through this wrap up this notebook.
Yeah, Spark is taking its time. It's thinking.
So
that's great.
That's actually
this is good advertisement.
Yeah. So would it take longer for the Spark code to run or to get Cape Python working with Dask?
Yeah, probably the latter.
That's a slightly facetious question, but yeah, what's the path of least resistance to get this PyData native, aka working with Dask?
Yeah, no, I mean, it was amazing when we launched it. The first two feature requests we got were just please integrate with Dask. So I was pretty excited.
And we've had that question in the chat already. So. Oh.
Yeah, no, it's next on our roadmap for the next pipeline that we'd like to integrate with. So, so we're hoping to have that out at the latest sometime in September.
That's exciting.
What I'm going to do. What I'm going to do is I'm going to actually hijack the screen if I can for 1 minute.
Do it.
I can go and look at some Cape privacy code because I've been looking at that code while you've been talking. I apologize. And let's see what would be challenging. So we do this a bunch with Dask. We go into other libraries and see how hard it would be to parallelize them. So I want to show two examples. This is the tokenizer code. And look at the date truncation example. These are the two examples that Katharine brought up in the first example. The tokenization, I think, is mostly, there's a bit of cleaning on the tokenizer. This is all normal Python stuff. Call series apply. And that would probably just work out of the box. I suspect that something as simple as tokenizing these things would be pretty trivial. I suspect if you turned your pandas data frame into a Dask data frame, it would just work today. There's actually no extra work. But if we move on to rounding, so here we're rounding the date times to things like dates or seconds or whatever. You guys are you're switching from pandas into NumPy, calling as type with the like sort of Baroque NumPy strings. All of this would work with Dask also. So this API would be just fine. But then at the end of it, you turn that NumPy array back into a pandas series by explicitly calling the pandas series constructor. And that will not be Dask compatible. That's going to make a pandas series out of what might be a Dask array, a bunch of NumPy arrays. So mostly everything is just fine because of the API compatibility between Dask and NumPy and Pandas. But every once in a while, we run into these explicit calls to the Pandas library, and those are the things we need to switch out. So we might instead say, grab the type of the input. Maybe replace pandas.series with the type of X. So if X is a pandas series, it'll be the same result as before. But if it's a Dask series, you'll have the Dask constructor instead. So some small changes like that are probably all you need to make this Dask compatible. But it should be pretty easy. I bet we could do it in a day. Sorry. I'll stop sharing my screen and give it back to you, Katharine. Anyway, it gives people like a sense for what we go through as we parallelize different PyData libraries.
Yeah, that's super exciting. That also feels more like intentional, right? Rather than the explicit casting call to keep it what it originally was.
And we gave Spark, slow Spark, time to catch up.
Exactly. It has to think, This is just me running Spark locally too, by the way. And it's only 7 gigs of data, which is slightly disturbing. So what I wanted to show here is the perturbation of the passenger data. And so we can see the data shift, right? It retains, some of this same overall distribution, right? We have a little bit of a jump here. However, we can see that the values no longer are, we can't, if we needed to make inferences about, let's say, single passenger rides, we no longer can do that. And so I bring this up because when we think about perturbation, especially when we get into more advanced techniques like differential privacy, we have to make decisions there about what's the massive amount of data that we're using. So the larger the amount of data, the less this perturbation will matter, or the less it will affect our results. And then secondly, what methods might we need to do to preserve individual privacy, but to be able to make group inferences, right? So one of the principles of differential privacy is our ability to protect the individual privacy, but still make some sort of global assessment. And so we can think of this as almost, I take these and then I would like to subtract, 1 or 1.5. So we can, there's some trade-offs there, and, we can talk about them deeper, but this basically, I just wanted to give a light view of when we think about perturbation, especially as we get more advanced, there's ways that we can preserve individual privacy and still make group choices, but there's also other ways where we destroy information, and you should, kind of think about those trade-offs as you make them and figure out what's the good compromise there. We'll be releasing more stuff on this, and you can also learn more. Again, open differential privacy, I feel like it's a great community for starting to think about this. And recently, Google also released differential privacy on Beam. We plan on eventually supporting that in Cape Policy too, the ability to leverage the Google library there.
So this then dovetails nicely with what we wanted to cover at the end is thinking more about inference and or machine learning and how that interacts with privacy, whether this trade-off between privacy and performance is actually real, and how privacy can actually, I think sync well with distributed computing when building machine learning algorithms via such things as federated learning. But there's a whole world there, and we've got maybe 10 minutes left. So whatever you'd like to discuss with respect to machine learning, we'd be really interested in chatting about.
Yeah, I mean, so I was talking a little bit with Hugo about this earlier. Sometimes we also muse about this on chats. And I'd be curious, Matt, your perspective on this now that you're hopefully caffeinated enough and awake enough that you're good to go.
And the sun is rising in California.
I'm caffeine free. Sun is my caffeine.
Yeah. Matt photosynthesizes these days. It's a new thing they do in California. It used to be keto, and now, I'm just kidding. Clearly, people can't photosynthesize.
Yeah, no, I mean, I mean, I think it's interesting that some of the privacy problems that we're in now are because of the availability of compute in a limited amount for a limited amount of individuals, right? So when we think of the initial supercomputers, it was like, can we have all this data held in one place and then process it in one place? And then the advent maybe of some of the earlier big data stuff like Hadoop, right, was like, I have all this data, it no longer fits on my one machine, but I like to process it in one central location, right, when there was like physical clusters. And then now, you know, with cloud, more distributed compute available to more people, maybe distributed compute and distributed data are allowing data to be maybe held by different people and still computed upon, right? And maybe the end goal, at least I would say as the privacy activist part of me, is that maybe data never even has to always go into the cloud. Maybe there's other ways where we can still get the benefits of data science and machine learning, where we don't have to actually transfer our data. And this has, I would think this would also have great implications for, you know, kind of the trust of data overall, and maybe the trust of our profession overall, from a societal point of view or from a humanity point of view. Which I think is, you know, every time we suffer a data breach because something was misconfigured or something was left open, I mean, these are human mistakes that we will make. You know, there are mistakes even in automated systems that we make, right? So it's kind of about, can we move to a place where we can actually reason about data without always taking it from someone and storing it somewhere else? And this is where I think federated learning and federated analytics hopefully have, you know, a strong future in our world, which is again the ability to compute a machine learning model or train a machine learning model with data across a distributed series of, let's say, devices, right, or compute clusters or whatever, where the data have to actually.
I can give an example I think that Google was thinking about several years ago. It's also very interesting that Google's thinking about this for different reasons, for latency reasons, all of these types of things. But it's, if you, for example, if you've got data on your cell phone, they will build some global model, and you'll have a local model on your phone running some sort of TensorFlow, I think basic form of TensorFlow, and you'll build the model and you'll transfer that local model up to their global model, and they'll combine hundreds of local models and average out over them, so that at no point is any of your data or even your model. And remember that you can extract data from models as well. But at no point is your data or your model stored per se until it's averaged out over a bunch of others. So I think that's one of the I think paradigms of federated learning, right, KJ?
Yeah. One of the things that our research team at Cape Privacy has been working on, shout out to Morten Dahl, Jason Mancuso, Yandu P, and Dragos Woturo. They've been working on really like, how do we have what we call secure aggregation points? Because honestly, let's say if your data, Hugo, is a lot different than my data, then we can actually make some let's say reasonable presumptions that your gradient updates will be significantly different than mine, which may or may not, like we could think about that, whether that leaks privacy, depending on the sensitivity of the information, this might also be considered sensitive. So one of the things we're working on is how, in a federated sense, do we even allow for extra levels of protection, like secure aggregation points, which might use encryption in order to kind of send an aggregated grouped update to the central location.
So if I can, I want to jump in for a second. So you painted this nice story of computation, access to computation, cloud changing, and then data privacy. I think we've been solving in the community, we've been solving like the access to computation problem. Cloud is around, tools like Spark or like Dask give us access to parallel algorithms. You know, at COIL, we're trying very hard to make it easy to use the clouds, that any individual can, you know, swipe a credit card and get access to a bunch of GPUs if they want to, for example. annex all the public data that we have, right? The New York City tax data set is there, the Chicago crime data set is there, the WHO is interesting data sets. Those are all great. But then we get into sort of harder problems, which we were talking about now, which is like there's all this private data, where actually is where a lot of the value also is. We can do things like federated learning. My keyboard on my Android app is presumably training something, but there's still infrastructure that's there, and that's still centralized. I do not have the ability to run or learn models on everyone's keyboard. Only Google has that. Now I'm feeling better because Google isn't necessarily reading all of my texts to my friends, and I feel more there's more privacy, but there's still not democratic access to this data. And my guess is that's actually not in the cards near term. If you look at who here uses OpenStreetMaps, right, for example, rather than Google Maps. Now maybe you do, Katharine, but there's still like infrastructural things, even though data might be decentralized and more private, access to that data is still going to be centralized, I think.
Yes, or like the ability to have enough users to allow you to make an inference that's, let's say, differentially private, right? So some of the really cool research coming from some places, I mean, it breaks down unless you have, millions of individuals in your data set, which not everybody has access to. It's interesting because one of the things that we've been exploring within federated learning has been, can several organizations use federated learning to create a model, therefore giving them, let's say, a more of a competitive advantage versus, let's say, a large incumbent. So this might presume that several fintech companies, let's say, get together. They would like to train a credit model. They want to do so in a privacy-aware way, or maybe even in an encrypted way, so that nobody can see any individual row of their data set, but that together they kind of can make a stronger model, a more performative model that might, let's say, rival one of a large bank. And so I do think there is some ways that this can kind of address that, but I mean, you're right. I mean, I'm not sure if everybody's going to go buy a non-Android or non-iPhone phone, right? And that this is.
That's a good example though, because it's privacy motivated by greed. And if there's anything more productive than greed, I haven't found it
Yeah.
yet.
Okay. I would say this is like democratization of data models, right? Like maybe not to the individual, but to like that don't have to work at Google to build the best model, for example.
All the regional banks can coalesce and beat out Capital One or something.
And even at the top in tech, we are seeing privacy as becoming more of a conversation. I think Apple, and we've discussed this, KJ, in public and a lot in private conversations, but Apple as a differentiating factor is really pushing its privacy these days. They also have the benefit of having a business model which allows them to do that, I think.
Yeah. I mean, I think obviously, like one of the things that we're hoping is that people don't see can see ways where they can increase privacy and still meet whatever, objectives or goals or pressures they have at their work environment, right? And I think that these are the small choices that we can make. Eventually, it hopefully adds up to kind of a sea change where we think differently about using, let's say, completely unprotected raw personal data for our daily data science, and we start with small steps. It's okay to just have some vegetables with your favorite food. They can be delicious too, and we're trying to make privacy delicious for the Pi data world.
So we're going to wrap up in a minute. I'd encourage everyone to check out Kate Privacy. Get on the Slack group if you're interested. Also, check out Coiled, where we're going to be launching our beta very soon. You can sign up for our closed beta currently. But check out our website. It'll be great to have you on board. As I said at the start, we're building products to scale existing Python workflows and make enterprise and collaboration ready Dask-based projects. To to wrap up though, KJ, I have one question. What type of incentive structures need to change for organizations and teams and working data scientists to care more about privacy and to start using these types of libraries in their everyday workflows?
I mean, perhaps my sample is biased. This is most likely true, but I see a lot of data scientists that I meet and speak with regularly kind of asking more critical questions about our field in general, from maybe, let's say, like a fairness or equity perspective, but also from a privacy perspective. I think that the incentive is already there from just we're humans, we care about other humans, we want to treat data with respect. I would argue it's less of, do we change the incentive structures, and it's more, do we make these things easier and more accessible? Right? Because if you make it really hard to do the right thing for privacy, then who's gonna, who has time for that? I just think nobody has time to become a data privacy expert just to do the right thing with their local data set, right? And so that's, one of the things we're trying to work on. I would love feedback from folks. Is it accessible? Is it easy? What topics in privacy would you like to learn more about or become more familiar with? I really see us too as like we're part of a mission that can hopefully help people solve the hardest problems, right? Which I would argue are maybe like with the most sensitive data, because they're about health and aging and financial crises and other types of things like this, that we can feel more comfortable that privacy can be, let's say, enhanced or can be preserved in certain ways while we still solve really cool, hard problems with data science. And yeah, that you don't have to become, again, an expert to do this. Like, you can opt in without being an expert.
So I totally agree that a lot of data scientists I speak with on an individual basis care about this, but whatever the saying is, if your paycheck depends on something, that's what you'll. I can't remember what it's after midnight. So for what that's worth. But I mean, for a lot of organizations, there is, like, I suppose, to be perfectly blatant or explicit, like a big data surveillance infrastructure set up, which is monetized.
I think
yeah, I mean, if you work for Palantir, you should probably just quit. Just putting it out there.
Okay.
I think if you work for Palantir, you're also frightened of regulation. You're frightened of breaches.
Yeah.
I think that's what I think, like, we intentionally at Quill, we've got a database of users. There's not many people in it yet, but we intentionally don't record certain information just because we don't want to have to deal with this stuff. And I think that's been a big realization over the last few years, is like, actually, like, data can be a liability. And you do not want to have highly sensitive data in your database because it is a pain to remove. And that's where I think a lot of this comes from. It's not from like an emotional, moral, ethical value standpoint. It is from a liability standpoint. And for that perspective, privacy is super, super valuable. Again, privacy through greed. Greed is the biggest motivator.
Yeah, so there are stronger regulations because of the Privacy Shield ruling last week. We will see if European resident data needs to stay in Europe. I mean, there's many signals that European lawmakers are making that they will have machine learning or automated decision-making specific regulation within the next few years. And so it's not, at least from this European perspective, I live in the bubble of Germany, is, that there is a strong opinion here about this. And it'll be interesting to watch and see how that changes now that the states within the United States and numerous places all around the globe, for example, Brazil's law is up next in the next month, that whether this wave of privacy regulation means that our industry has to change, whether or not people want to change.
Great. And with that, should we close things out?
I think so. I'd just love to thank Katharine for joining us today. and letting us know everything that's happening at Cape Privacy, taking us on a tour of all the transformations and the work they're doing and how we can use it in our data work as well. So thank you so much, KJ.
Thanks, Hugo and Matt. I had a lot of fun chatting today. And thanks for everybody who joined us.
Yeah, thank you so much. And thanks, Zach, for looking over my shoulder the whole time as well, as he does with all of us.
And on that,